All right. This is section 3.4, slope and rate of change. What is slope? So, slope is how much something changes over time. These two visuals are kind of give you an idea about slope. Think about someone climbing a mountain. Some mountain edges are very steep. Some mountain edges are more like this. So if you look at this mountain edge, it's kind of like that. If you draw kind of a line there. This is also a slope. So you see this slopes. This is also a slope. So that's a slope. And notice it's some more steep than others. For example, this mountain slope is not quite as steep as that one. That's very steep. Um, the reason I'm referring to mountain slopes is because we're going to get into what slope is, and there's a letter we use for it. So when we think of slope, we should think of mountains. Mountains have slopes. So let's talk about what slope is. Slope, I apologize, is how much something changes, aka rate of change. So let's think about some examples of slope. Speed is a slope. Fuel economy is a slope. Wage or salary is a slope. Speed is measured in miles per hour. So if I want to get from Starkville to Columbus, how do I do that? Well, I could take 45 and I can go about 60 miles per hour on the road, or I could take a different road. I could take that road that goes past EMCC, Mayhew campus. And I can't necessarily go 60 miles per hour. I can go, what, 45 miles per hour there? So, and if I go 60 miles per hour, maybe even 65, 70, 65 even, I will probably get to Columbus faster than if I go 45. Um, if I'm taking a road that goes 35 miles per hour, I'll probably get to a place slower than if I go 45 miles per hour or 50 miles per hour. My speed is how much it changes. It measures the rate of change. How fast does it take me to get to Columbus based upon where I go from? Fuel economy, miles per gallon. You fill up the tank of your car. How many miles does it take for you to spend a whole gallon of gas? Or you could think of it as how many dollars do I have to put in my tank for me to fill up my tank? Or you can think of it as how many gallons do I spend in an hour? If I just drive for an hour, so let's say I drive about an hour, let's say I drive to Columbus or I drive to Tupelo or something, and I drive there, it takes about an hour something, hour and change to get to Tupelo. How many gallons of gas do I spend? Do I lose? So how much does it change? That's a really important question if you're trying to think about what car you want to buy or what truck you want to buy. Wages and salary. Well, wages and salary can be expressed in dollars per hour, or it can be expressed in dollars per month. So dollar per hour, dollar per month. You might make $8 an hour, or you might make $800 a month. That's just a different way of saying it. How much? So at the beginning of the month, let's say you have $200. By the end of the month, if you make $800, for the month, you should have about $1,000 at least. So that's the rate of change. How much does the amount of money in your bank account change per month? That's something you're thinking about constantly. If you have a job, If you're working, you're constantly thinking about how much is my bank account balance changing per month. So a slope is basically a rate of change. Now we're going to abstract it a little bit and use it for these lines, but that's kind of what we're talking about. How much does something change? So when we talk about the slope of a line, we use the letter M to refer to slope. Remember, M stands for mountain. Mountains have slopes, so M is slope. M is measured. Now, remember, go back when we think about our example of slopes. We had miles divided by hour. We had miles divided by gallon. We had dollars divided by hour. In other words, we always took something and divided it by something else. So when we find the slope, what we do is we find the change in y over the change in x. Well, how do you find the change in y over the change in x? Well, basically what you do is you take y2 and you subtract y1 divided by x2 minus x1. We also call this rise over run. It's a shorthand we use for slope. Let's go ahead and keep going with that formula. Same idea. Slope is rate of change. Slope is also the change in y over the change in x. That's a formula. If we see the letter M, it refers to slope. So if you see the letter M, that means slope. And we have the slope formula. That is a slope formula. We'll see how to use it in a second. So, how do I find slope when I have 2 points? Step 1, we label our points. We always label our points. If we don't label our points, we will get things backwards and confused. So we need to make sure and label our points. It's helpful. When you're working a whole bunch of math problems, things get backwards in your head. That's what happens. It's not really anybody's fault. It's just kind of what happens. You're working a bunch of problems, things get backwards in your head. If we label our points early on, we can just kind of go back and we don't have to think about that stuff anymore. All right, step 2, we plug the corresponding values into the slope formula. Step 3, if we have 2 negatives, so if we're subtracting a negative, a minus minus, we do a little step in between so that we don't mess up some stuff, some sign stuff. And step 4, we work on the top of the fraction and the bottom of the fraction and divide. Okay. So example 1, we're going to find the slope between the points of the line through the points 2, 3, and 6, 1. So step 1, we label our points. 2, 3 is an ordered pair. Every ordered pair has an X and a Y. So the first point has an X and a Y, so why don't we call it X1 and Y1? The first X and the first Y. X1, Y1. Sounds like a good idea to me. Sounds like a plan. All right. Then we have 6, 11. 6, 11 is our second point, right? We have 2 points. The first point is 2, 3. The second point is 6, 11. But every point, every ordered pair, has an X and a Y. So presumably, we could just call it X2 and Y2 because it's the second X and the second Y. X2, Y2. So we label our points X1, Y1, X2, Y2. Then we have a formula. The formula says that the slope, M, is equal to the Y2 minus the Y1 and the X2 minus the X1. So let's kind of go here. Let's see if I can get here. So Y2, we already know what it is. It's 11. We labeled that, so we put 11. Minus y1, we know what that is. That's 3, because we labeled it. And then we have x2. We know what x2 is. It's 6, because we labeled it. 6 minus x1. We know what that is. That's 2. You know why? Because we labeled it. If we didn't label it, our brains would get discombobulated and we might get them confused. But if we label it, we know what it is already because we labeled it. All right. It's like you have jars in your kitchen and you just label them so that you know what they are. You have a salt shaker and a sugar shaker. Salt and sugar looks very similar to each other, but if you label them, if they're labeled, it's pretty easy to figure out which is which without having to open it up and test it. All right, so we label things so that we don't get things backwards. All right, then we work out the tops and the bottoms. 11 minus 3 is 8. 6 minus 2 is 4. 8 divided by 4 is 2. All right, this goes in our calculator as 2 separate steps. 11 minus 3 is 8. 6 minus 2 is 4. We don't try to put this all in one time. If we try to put it all in one time, things get really messy and they go wrong. So we do the top, we do the bottom separate, then we divide. And we get 8 divided by 4 is 2. So, good. Example 2. Same methodology. We take our points, we label them. x1, y1, x2, y2. We plug into the formula. M is equal to y2 minus y1 and x2 minus x1. So what is y2? Well, we labeled it, it's -10. Minus, what's y1? It's 8. So we put 8. x2, -5. Minus x1 is -3. So notice that I put that in parentheses to kind of help me keep it separated. You don't have to, you can just put it down without putting it in parentheses. I put it in parentheses because it helps me to separate it out and keep things a little bit separated. But if it's not helpful to you to do that, don't do it. Now, I noticed that I have a minus and a minus next to each other. And what did we say a negative times negative was equal to? Well, we said a negative times a negative equals a positive. So when I see this minus minus right here, my first thought is that's confusing. I do not want to have to deal with subtracting negatives. That is nonsense. So the first thing I do, if I see a minus and a negative, or a negative negative, or a minus minus, think of it whichever way you want to think about it. The first thing I do is I change it to a plus. Now, I don't change that because there's no reason to change that. I mean, it's not a minus negative, it's just a minus. But this right here can cause people a lot of grief, this minus negative business. So what we're gonna do before we do anything else is get rid of this problem right here of this minus negative nonsense. We're gonna change it to a plus. Now I want you to notice several things. Number one, this -5 didn't change. This -8 didn't change. This -10 didn't change. The only thing that changed was this minus negative. That's the only thing that changed. When we have a minus and a minus next to each other, or a negative and negative next to each other, think of it whichever way you want to think about it. When those things are next to each other, we change them to a plus. We don't have to change anything else. We only change it when we have a minus minus next to each other. That's the only time we change it. Now, that's a step we do in between so that we don't get confused about that minus negative business. All right, now, once we've taken that step to change this to a plus because it's a minus negative, then we just do the same thing as before. We go across the top. Our calculator will do this for us. -10 minus 8 is -18. -5 plus 3 goes in our calculator, gives us -2. -18 divided by -2 goes in our calculator, gives us +9. All right, so again, our calculator is our friend. Our calculator wants to help us. We don't need to do a lot of stuff in our head until we do it a whole bunch of times. I even still put stuff in my calculator sometimes because I'm like, I am tired. I do not want to think. I'm going to put it in my calculator because my calculator is my friend and it wants to help me. All right. Example number 3. Find the slope. We are given 2 points. The 2 points are 9, 10, and 12, 10. The first thing we do before we do anything else is we label our points. X1, Y1, X2, Y2. Then we plug it into our formula. We know what everything is because we labeled it. It's 10 minus 10 and 12 minus 9. I won't belabor that point. I think we got that basic concept. All right, we go across the top. 10 minus 10 is 0. 12 minus 9 is 3. We go to our calculator. Our calculator is our friend. Our calculator will tell us things. We go to our calculator. Our calculator tells us that 0 divided by 3 is 0. Okay. Example number 4. Find the slope. And do not skip any of these examples. So don't say, well, I got example number 1, I can do all the rest of them. They're all different. I want you to go through all 4 examples. Example 1, example 2, example 3, and example 4. I want you to go through all the examples. They're all really important. All right, example 4. The slope between 7,4 and 7,6. Label our points. Plug in our formula. Okay. No negatives to deal with, so we're good. Okay. 6 minus 4 is 2. 7 minus 7 is 0. Then we go to our calculator. We type in 2 divided by 0. Not 0 divided by 2, but 2 divided by 0. We type that in. And our calculator tells us, nope. Your calculator will not do that. Your calculator will say, sorry, I don't know what you're talking about. It will either say error, or it will be like, no, just not going to do it. Now, here's why it's doing that. It can't do it. It is literally impossible for your calculator to take 2 divided by 0 and give you a number. It is literally impossible. You can try it on 1,000 calculators and it will never give you an answer because you cannot divide by 0. Now you might ask the question, but we just divided by 0. We said 0 divided by, what was it, 3 or something? That's fine. Yeah, you can divide by 3. But when we say we can't divide by 0, what we mean is this. We mean 0 cannot be in the denominator of a fraction. It cannot be on the bottom. If we have a 0 on the bottom of a fraction, we have a problem. You cannot have 0 on the bottom of a fraction. And right now we have 0 on the bottom of a fraction. And if you put that in your calculator will tell you that that is impossible because it is. That means that that quantity has no definable analog to us in the universe, really. So it's undefined. Or we use another thing, we say does not exist. 2 divided by 0 does not exist, or D-N-E. So we either say undefined or we say does not exist. are DNE. The computer will say undefined. So you need to be familiar with that term, undefined. Again, we cannot divide by 0. It doesn't work. Your calculator will tell you that. If you ask your calculator will say, no way, we can't do that. So listen to your calculator. All right, so that's 4 examples of how we find the slope between 2 points. It's just a formula. We practice the formula. We do the formula over and over again. We do it until we're blue in the face, until we are tired of it, until we are dreaming about the slope formula at night, having nightmares that the slope formula is chasing us through the woods. All right. So that is what we do. We practice. This practice makes perfect. All right. There's actually something that's a little bit easier to do to find slope, because sometimes they just give you an equation and say, hey, what's the slope? And so what you can do is you can literally just go, you can look at it and be like, oh, that's the slope right there. Just point at it. You can be like, oh, there it is. In standard form, we can't really do that, but in slope-intercept form, which is y equals mx plus b, it's really easy to figure out the slope of a line. All you have to do is say, what's the number that comes right before the x? So in the line y equals 3x minus 4, it's 3. That's it. That's all you do. You don't do anything else. That's the answer. Or in the line y equals negative 4x plus 7, it's negative 4. That's it. That's all you do. You don't do anything. You literally don't do anything. Like, you look at it, you read the number out, and you kind of process it in your brain and then say the number. That's the steps. The steps are look at it, process it in your brain, and say the number. That's it. Those are the steps. That kind of tells you a similar idea. The slope is here. That's the slope. The slope is 3. That's the slope. The slope is 3. All right. So we might have asked a question. What is the slope of the line 5x, y equals 5x minus 7? It's 5. How do I know that? Because that's the number next to the x. It's 5. What is the slope of the line y equals 1/3 x minus 8? It's 1/3. How do I know that? Because that's the number next to the x. Do I have to do any work for it? Nope. Do I have to like work out an equation? Nope. A formula? Mm-mm. I gotta subtract? Nope. Add? Nope. Do I have to? Nope. You don't have to do anything. All you have to do is look at it. It's 1/3. That's the answer. It's 5. That's the answer. You look at it, and then you know what it is because you looked at it. All right. Those are really easy. Don't overcomplicate those. All right. Last but not least, we have an example. Graph the points 4, 2, and 2, 8. So that's what I did there. Was I graphed the points 4, 2, and 2, 8. I went 1, 2, 3, 4 over, 2 up, graph the points, 1, 2. So over 2, up 8. Find the slope. You plug in the formula, you get the thing. And the next section we'll talk about negative slopes and positive slopes and parallel and perpendicular. For right now, the basic idea is you get a formula, you get some points, you label the points, you plug in a formula, or you look at it. Sometimes you just look at it and you go, that's the answer. Depending on what kind of question you have. So again, practice makes perfect, so perfectly practice. All right, that's the second example. That's it. Cool. Hmm, sorry.